Hi, welcome to the lesson about fault tolerance. So it's a quite important topic because as each pipeline, stateful processing, stateful jobs are not an exception and they can also fail. And of course, here you should take care of, I would say, offset checkpointing, like for usual streaming jobs, stateless streaming jobs, but you should also take care of the state store checkpoint. And in this lesson, we will see how. And yes, as I said, I can almost guarantee you that either your stateful pipeline will fail at some time because maybe of some poison pill message, or maybe because of some hardware issues that are temporary, but still you will need to either relaunch it or either your pipeline will relaunch by itself. But yes, there is some kind of fault tolerance involved in that aspect. And if you are a lucky guy and your pipeline doesn't fail, well, I think that you will still need to stop it somehow in order to update or add some new features. And in that case, you will also need to have some kind of persistence for the state store so that when you restart your pipeline, you can restore also the state and start processing from the most recent point and not from the oldest message, because it will be obviously slow. And here is the stateful processing pipeline that you already saw in the previous lessons, and with the state store that can be local and or remote. And now when you simply get rid of the state store, so when you don't have any persistence for that, for example, when you have only the in-memory state store, well, your job becomes stateless when you restart it here, right? Because there is nothing left from the previous execution, any state, and you need to restart again from scratch. And there are three different strategies to ensure the fault tolerance for this state store. The first one is when you have this remote state store, so it's a remote database, and as long as it doesn't go down, well, you have your state anyway, so you don't have any extra mechanism for the fault tolerance for the checkpointing. Another one is when you have the local state store. As you remember in the previous lessons, I said that this strategy is, or at least this local state store is the most common solution implemented in modern data processing frameworks. Well, here you need to rely on some checkpointing mechanism. And finally, yes, you can also take a bet on your luck and say that you don't need the checkpoint because your pipeline will never fail, or your pipeline will be never restarted due to some application updates. And in this lesson, we will really focus on this local state store part because, as I said already, it's one of the most commonly implemented approaches in streaming processing frameworks. And I think that you, as a data engineer, you will probably work with it. Unless you don't want to go into or invest your time into learning a data processing framework, you prefer writing stuff on your own, where in that case maybe remote state store will be your friend. But as I said already, also when you use the remote state store, it's a kind of checkpoint mechanism already, and you, instead of focusing on checkpointing or fault tolerance mechanism on the state store, you should rather need to ensuring the fault tolerance on your database by for example providing some backups, geo-replication, and stuff like that. So let's stay focused and analyze what's happening for the local state store and the checkpoints. And the first strategy is regular checkpointing. So meaning that whenever we finish some processing slot, typically here it will be a microbatch because I'm giving here the example of Apache Spark structured streaming. Well, we write the state to the remote storage. That is our fault tolerant storage. So we have the first job, microbatch, second job, second microbatch, third job, third microbatch. So here it's great because we have the consistency, meaning that when you have the job number 3 failed, for example, in the middle of the processing before checkpointing, well, you can simply restart the state from job number 2. On the other hand, there is also a drawback because, as you can see, it's an extra operation added to each microbatch, so obviously it increases your end-to-end latency. An alternative is the irregular checkpointing. So in irregular checkpointing, you define kind of interval for the checkpointing logic. So you say maybe one of two jobs are only checkpointed. Here you can somehow optimize the latency, but as you can see here, when your job 3 fails, well, you will need to start almost from scratch from the job number 1. And this irregular strategy, you can apply it globally, or you can also try to apply it at the task or operation level. And here we can see that we have two tasks, yellow and orange. And the nice thing is that both will not have the same checkpointing interval because they are unaligned, meaning that, yeah, you can see that the job that I will just maybe, yes, that the yellow task doesn't move, does nothing in the, I would say, second job because it's currently checkpointing, but the orange task is moving, is processing the data, and only the next job, the orange task, starts to checkpointing. So there, the checkpoints may have different event time alignment. And typically here it's dependent on the data processing, but at a smaller level of the task level, it's optimized for the latency, but of course, as you see already, it also has some implications on the consistency. And for example, you can find this kind of mechanism in Apache Flink. And the strategy is not the single one, the single point related to the fault tolerance. Another one is the checkpoint content. So what do you checkpoint? What from your state, what part of your state will be written to the checkpoint location? To the fault tolerance location. Sorry, maybe let's use these two terms interchangeably to define this fault tolerance storage. Here we have two choices. We can either store the full state, so every time, even if one state entry is not modified for several dozens of minutes, you will every time write it to your fault tolerance storage. Of course, you have much more data to write. Your writing will be slower, but when you recover, the recovery will be faster because you will not need to rebuild this state incrementally. On the other hand, you can also have something like delta state storage. Do not confound it with delta lake because delta is just to indicate here that we are saving only things that changed since the previous microbatch. So if we take our example of a state that hasn't changed since let's say 10 minutes, of course we will not write it for 10 minutes, we will write it only once it has some updates. And as you already see, there is less data to write, but the recovery process is slower. And let me show you that in a quite quick diagram. So here we are processing 3 records, and in the full mode we write 3 records every time. Now we are processing only 1 record, but remember we have already 3 records in the state store, so we write the 3 records with the yellow record updated. And now when it comes to the restore, well, we simply take the last version of our state store in the checkpoint location, in the fault tolerance location, and we load it to our application. When it comes to the incremental state checkpointing, let's take the same example, but with incremental logic. So here we have all 3 records, here we have only 1. And now when it comes to the restore process, we start by loading first the oldest version. Okay, it's loaded into memory cache, because remember it simplifies and accelerates a lot the processing. And later we update the keys with all new entries, I would say. So here we have only 1 update for the yellow entry, and we load it also from the state, from the fault tolerance storage, and update in memory. So you can see it's very incremental and it can be slow depending on the number of files you have to load. Okay, and that's all for this lesson. I hope it's quite clear, right, how to ensure the fault tolerance for your state store. Typically, we will see more, I think you will see it clearer in the examples I will give you just after in the demo lesson. So thanks for watching and see you in the next lesson.